All right. Well, I want to welcome everyone to our first water seminar in our the Water Center's Water Seminar Series. My name is Kevin Wagner, and I serve as the director of the Oklahoma Water Resources Center here at Oklahoma State. So a couple of things we're hoping to achieve with these water seminars is, number one, obviously, is to learn about all the great research that's going on around campus. We have a lot of great new faculty members here at OSU. They're doing great work on various aspects of water research. So we really want to highlight that. And but our hopes is that will lead to some new interactions, some new collaborations, some new research projects going forward. So we're going to have these events every third Thursday during lunch. So we've got 4 planned for this fall, and then another 4 planned for the spring semester, and we'll have a mix of both faculty members as well as some agency personnel presenting too. And so hopefully from the agencies we can hear about some of the projects they have going on, as well as research needs, some of the priorities that they see, and maybe even some opportunities that they're aware of. So anyway, that's what we're hoping to achieve through these. We do invite everyone to join in person, but we want to thank everybody that's joined online, because it's we know a lot of people from Oklahoma City and other areas of the state are interested in the research we have going on here and just can't physically make the trip. But if you're in the area, we'd love to have you join us. So our very first presenter today of our first seminar is Dr. Jamie Schussler, and want to thank her for being our guinea pig, our very first seminar speaker. But she's joined Oklahoma State last August in the School of Civil and Environmental Engineering. And prior to coming here to OSU, she was at Auburn University, where she received her PhD. Her research focuses on stormwater management, and she specializes in erosion and sediment control. And her work aims to find implementable solutions to manage increased stormwater runoff and sediment loads from construction, urban, ag, and reclamation sites. So with that, I will turn it over to Jamie.
Thank you so much, Kevin.
Sorry. Gonna work.
Just make sure. Perfect. Yeah. Thank you so much. All right. And I want to thank you all for being here and allowing me to be the guinea pig. I think going first is both a blessing and a curse. There's no expectations to follow up on, but I also hope that I'm getting you the information that you're anticipating today. So I believe the title of my talk was Stormwater Management to Prevent Erosion in the Built Environment. I just had one correction that I added as I was going through these slides, and it's to prevent erosion and sedimentation in the built environment. And so just want to thank you all again for taking your lunch to spend it listening to me talk about the things that I'm very passionate about. Okay, so why do I care about our water resources? This is very important to me to relate to you, but this is more than just my work. This is my life. Very thankful my fiance actually came to support today, but you'll see him in some of these pictures, and we spend a lot of time around the water. We're big fisher people. We love to hike around the water. We just think everything is much better either on, in, or around the water. And some other things that I really care about is just keeping our waters healthy, because we have our golden retriever Max. He's a pet posse dog. You might see him around. But when he's not working, we can't keep him out of the water. So whether this be the ponds on our property or creeks, we can't prevent it. So we want to make sure any water that he's getting in is healthy and not going to make him sick. And more so, I have some little nieces now, 3 and 3 months. They're also quite the water bugs. And so when I'm thinking about the health of waterways in perpetuity, this matters even more to me now that I have this connection and I'm seeing the next generation. I'm originally from Milton, West Virginia, or the lower Guyandotte watershed. One of the things that I task my students with when they start in my water classes is just knowing what watershed you're from and what issues that you're facing there, because in every watershed, there's very likely something that we could do better or improve. And so because I'm so passionate about these things, when I was thinking about a career and what I wanted to pursue, I decided to go into water resources engineering. Okay, now that's a really big realm, water resources. A lot of us in here work in water. Me specifically, I work in stormwater. And stormwater is actually a pollutant source that is getting worse. We're getting better in a lot of ways, or at least more aware of water pollutants. Stormwater is just something that even though we know about it, it's very hard to manage. Now, I've lived around different places, but a lot of the sites that you see are pretty common from place to place. This was down in Alabama when I was doing my PhD. This is just downstream of a construction site, hitting a receiving waterway. That's actually pretty clean and clear if we look over here, but we have large plumes of sediment coming off those sites. Here's some failed controls. I said, is this just an Alabama thing? When I first moved to Oklahoma, I wasn't seeing a lot of rain last summer. Some people even said to me, you work in stormwater, why'd you move to Oklahoma? We don't have any rain. Well, that certainly changed this summer, but I just needed to wait till the next season and went down to Edmond, Oklahoma with some of my students, and there was a site very, very similar. We have a receiving waterway and again, just huge sediment plumes coming off. There's got to be something that we can do to improve this. Why is it getting worse? There's a lot of reasons. I'm sure you could give me a whole list, but the two that I focus in is the shifts in hydrology, infrastructure, or ways that we were designing previously are just not up to par with what we need them to be now that we're seeing shifts in such extreme events. We're having much more frequent and much more intense rain events. And how we've been designing just isn't going to cut it anymore. The other big changes that we're seeing is shift in land use. This was a watershed that I worked in Iowa during my master's. In 2004, you see a lot of open green space. Flash forward to 2019, just 15 years later, the exact same frame, you see so much more development popping up. So yes, post-development, we have all of these impervious areas that's going to increase our runoff. But how did we get there? And so that's what I'm going to focus on today, is some of this erosion and sediment control that we can do to prevent some of the downstream effects of the sediment-laden discharge. What are some of those effects? Well, increased siltation and turbidity, that's going to affect our aquatic habitats all the way up. If all of our conveyance infrastructure fills up with sediment, we've reduced their flow capacity. So we can't be safely passing the same flows that it was designed for. And as I mentioned, increased rainfall, more impervious surfaces, higher runoff rates, higher flows. So we're already probably under-designed for the modern events that we're facing now. And so if we fill these up, we're in even worse condition. Of course, poor public perception. This is my favorite photo to show of this. This is a private landowner pond right off of a construction site. We have a recreational pond, whether that's used for irrigation, for giving a drinking water source to livestock, recreation. We see a little dock out there. Well, a DOT comes in, they're constructing 2 new lanes of highway, 12 miles long. You can expect that there's a lot of exposed earth, and we see quite a bit of sediment-laden runoff coming into this pond. This pond had already been dredged out 3 times, and you see how many practices are put in place. Water treatment costs. If we're degrading our water quality, our surface water quality, then we can expect we're going to pay for that on the back end. And then when we're talking erosion, I think a lot of people in here have an appreciation for nutrient-rich soil and good soils. And if we're just eroding that and washing that off, we can't keep up. The annual cost of soil erosion in the United States during construction on and off-site costs, $45 billion. So we're spending quite a bit of money on the effects of erosion and sedimentation. Now, we talked a little bit about stormwater. Stormwater affects a lot of areas. We have industrial runoff, agricultural runoff, urban runoff, and construction runoff. The two that I focus primarily in are going to be these urban and construction areas. And today we're going to be talking primarily about construction, or that development period. So that period that we're getting to the built environment or really altering those land use changes. A lot of people will say, well, if this is such a problem, if it's so bad, what are we doing about it? There is some regulation in place under the Clean Water Act. We have the National Pollutant Discharge Elimination System. And then in construction, we have the Construction General Permit. Here in Oklahoma, we know this as the OKR 10. This permit requires any construction that disturbs more than 1 acre to have a stormwater pollution prevention plan, or what we call a SWIP. So this SWIP includes erosion and sediment control practices, their design, the implementation, and the maintenance plan. This is a living document that is expected to be updated throughout construction. That way, if topography is changing, if land use is changing, we should be changing our practices or modifying our practices to make sure that we're treating those site conditions. So I'm going to talk a little bit about the projects I've done and where my research group here at Oklahoma State is going. So we'll be doing a little bit of back and forth. Please stop me if you have questions. I'll also try to keep up with questions on the Zoom. If I don't get to them during talking, we will get to them at the end. Okay. So one of the projects I first started on in this area and learned the importance was when I worked with the Iowa DOT to do some field assessments of their current stormwater pollution prevention plan assessment. So we were looking at erosion and sediment control practices they were using, how effective they were, and what we could do to improve them. So one of the first practices we looked at, I'm going to try to minimize this. One of the first practices we looked at were something called ditch checks or check dams. These are put within a channel or a conveyance to, one, try to slow flow velocities to reduce erosion within that channel and safely convey that stormwater. But they also have this effect where they create small impoundments within the channel. These impoundments are favorable for sedimentation, or that sediment to drop out. So we had several different practices in the field. You can see some control points here that we had to survey erosion and sediment deposition. And we looked at those weekly and also rainfall on site. I heard several of you talking about runoff events, and I knew exactly how many runoff events there were on my master's project too. So the first one we looked at, which a lot of construction operators are using or know well, is this silt fence. So silt fence is a common ditch check, but also perimeter control that they put around the site to try to keep sediment on site. Well, the standard installation just included these steel T-posts and this geotextile fabric that was attached with zip ties. When you put this in a conveyance channel, you have high flows and concentrated water. And you can see right here, it comes right to the middle or the lowest point in the channel. Well, over time, this hydrostatic pressure causes some deflection of this T-post. That soon leads to that geotextile being dislodged from the ground and the sediment washing out. So we monitored this practice over a construction season, and we had 3 in the field for triplets. The average sediment deposition was about half of a cubic foot. So we looked into the literature and what other places were doing. That's the one big thing with erosion and sediment control. It's really not scientifically tested or based in their design. It's very much rule of thumb. And everybody does it a little bit differently. So we looked, what could we do to improve this, to try to prevent some of these failure mechanisms from happening? And so we found this V-shaped stitch check, which was interesting because you have this vertex here. All the water is very concentrated right to this point, and we cut the fabric just a little bit lower. And there was a wire reinforcement on the back. Well, by cutting that fabric just a little bit lower, we created a weir. So we were controlling where the water was going, where it was dewatering from. And you can look just visually from the last picture to this one, the patterns of sediment deposition going much further back in the channel. Okay, so here's what we were seeing for deposition. And then we see a much wider deposition pattern happening. Well, after surveying, so we did some ground surveying and also some aerial inspections, we found that the average sediment deposition was about 2 cubic foot. So we increased the sediment capture behind each of these practices by about 4 times with just a few changes. Now there is an additional component with that wire reinforcement. So we're thinking here probably an increased cost. The DOT is concerned about that kind of thing, which we'll get to in just a minute. Now, another very common ditch check is what I call a wattle, some people call socks. But this is going to be a tubular device that has some sort of fill material. A lot of times it's a natural material, like a wood chip or a straw, and then encasement on the outside. So essentially a sausage. And then we're staked through with wood stakes. Contractors love these because they're very easy to install. They're just rolled out and staked right through and they can move on. These get installed much faster than silt fence, so very favorable on the construction side of things. Now, if we look here, this is the upstream side, we see some patterns even of erosion happening around this wattle. So maybe some deposition in the middle, but some patterns of erosion on the upstream, and we can really see those on the downstream side. So what's happening here? Well, depending on what that fill material is and how well staked it is, those wattles can become buoyant and flow can just bypass right under them. And that's what ended up happening. We're getting some undercutting occurring. And so about 0.1 cubic feet sediment deposition on this wattle. Again, look to other places. What can we do better? Looking in the literature, what can we do better? And we see this non-destructive or TP or A-frame staking. It's called a number of things in the field. But the stakes don't go through the wattle. They go on the outside. And with that A-frame, they're putting some pressure on the top of that wattle. So it's not able to float up quite as easily. We also have this natural fiber underlay. And some, if you look up in the detail, some sod pins. So we're able to go through just the encasement through the underlay to help with some of that ground contact. And so that helps prevent some of that undercutting. And visually, you can see deposition happening. We had about 1.5 cubic feet of sediment caught behind this wattle installation. So again, additional components, but quite a big change in how much sediment we're capturing on site. Now, if you compare those, anything that wasn't caught in this standard wattle installation, we can assume that's just running off site. Well, the DOT wanted to know a lot. Of course, performance, we're trying to put some science to these practices. And then they're also going to be concerned about cost. But when we did the analysis, the DOT really liked what they were seeing. And my master's project influenced a change in specifications at the Iowa DOT. That's when I really got hooked on research. And that's what I tell my students. Your research can make a really big change. So maybe for some people, this just looks like a different drawing up here. But just want to call you to, if this wattle installation replaced this one on the site that I was working on, there were 3,000 500 ditch checks installed on that single project. Okay, if we did the silt fence, change the silt fence from the standard to the modified, we would be capturing, it's hidden here, we would be capturing 18 truckloads of sediment with the modified, as opposed to 4.5 truckloads with the standard. So that's quite a big difference. I mean, if we don't make these changes and we know that we can do it better, we're just dumping truckloads of sediment into our surface waters. Same thing here with our wattles. If we don't make that change, we're dumping 13 truckloads of sediment into the surface waters. So these little changes can have quite a profound impact. Okay, now, what are the design principles behind installing a wattle or putting these in your plant?
Those positive segments.
Mhm.
What they have on the soil property.
Yes, so they were a sandy clay loam. That's my USCS that I have on the top of my head. What else would you like to know about them?
Don't you think that will affect the soil?
Absolutely, yeah, absolutely, that's true. Depending on what soil you have on site, it's going to affect your performance is going to be affected by that. Here we had pretty fine soils on the site. A lot of times with these ditch check practices, we're only going to be capturing those coarser grains because they can drop out of impoundments very quickly. Now, the one thing to consider about these impoundments is their maximum height is only going to be the height of that wattle. And so it's a shorter distance to fall out of suspension as well. So if we can catch some stuff in the channel, that's great. But you're right, it is going to be affected by soil properties. So when we're talking about design principles with ditch checks, we consider the height of the practice or the height of the wattle, which was a great segue, thank you. And then the slope of the channel as well. And we can come up with our spacing accordingly. Now, when we were in the field and looking at what was happening, even if it was specified in the design plans to be installed like this, they often were not spaced perfectly. So we had these areas of subcritical or less erosive flows and these areas of supercritical or very fast erosive flows. And so we wanted to look at how to help with the design and the implementation. And so part of that project was to come up with a design tool to help implement some of these findings. And so just some simple with the channel geometry of the site and what practice was desired, it would output the ditch check spacing and then also would put the quantity that was needed, whether that was in linear feet, so going across the channel, and then how many were needed down the channel. We sent out for cost estimates from the common erosion and sediment control suppliers of the area. We have 5. And then we could also tell them, based on what practice they were using, about how much it would cost to properly design that channel using ditch checks. So up here, they could toggle between silt fence, wattles, or rock. And this has been picked up not only by the Iowa DOT, but several others. South Carolina also uses it. So that's kind of where I was. And when I got here, I was thinking about, what do I still want to know? Or what do we need to know? Well, we took some of these practices and we're still putting a lot of synthetic materials out during construction. And as much as I would love to tell you that they get picked up, a lot of times it's just not the case. And so there's been a call to try to make changes to more wildlife or eco-friendly erosion and sediment control practices. People love the silt fence. They really don't want to give up on it. But we do have some more natural alternatives. Now, the wattles I showed you were encased in a sock, but they also come encased in like a jute netting too. So there are some changes to be made, and we have to answer these calls. So we are looking, I'm working with Dr. Mary Foltz, who's an environmental engineer, and one of my grad students, Cheyenne, on trying to come up with a quantitative sustainable design for erosion and sediment control. So this considers the cost, but also some of the environmental impacts. So the first thing we did was to try to tackle that cost piece by sending out a Qualtrics survey to all 50 DOTs. The reason why we use DOTs is because they're the major construction facilitator in most states. On average, a DOT is going to have about 250 active construction stormwater permits in a single year. So send out a survey to them asking about various components of their stormwater management plans and inspections. We found out the DOT is primarily conducting their own inspections, so not a lot of accountability from the outside. And about 2.5% of the construction project budget is spent on temporary stormwater management or erosion and sediment control. So when we're thinking about common erosion and sediment control practices, we started mapping. We had these state answers, I believe it's 16 state answers so far. And when we start looking at the results, we're finding that there's quite a wide variety in cost, but also implementation. Who is using what practices? There are some DOTs that have quite a big push towards some more natural practices and will spend the extra money on them. We can see wattles are more expensive than silt fence for DOTs to use. Maybe they're better for the environment. We're still trying to figure that out. States like Minnesota, some in the Pacific Northwest, they really have this push to get synthetic materials out of construction stormwater. So some people are willing to take on that cost, but we're finding there's just really not a strong trend just yet. So I mentioned we're assessing costs and environmental impacts. Well, how are we doing that? We're using this program, SIMA-Pro, that is a life cycle assessment tool that Dr. Foltz is well equipped in. And we are trying to get these erosion and sediment control components and how much of these components are being used on a project. So we first went into the Oklahoma Department of Transportation specifications, came up with a catalog of what materials are being used, how much are needed, and then we set system boundaries. So we're using a standard drainage trapezoidal conveyance channel for perimeter control, looking at 100-foot span because we figure that's easiest to extrapolate from, and then about 1 acre for some of these erosion control practices. We can plug in that quantity into SIMA-Pro, and we'll get some of these impact categories like ozone depletion, global warming, eutrophication, etc. Now we're still in the very early phases of this project, but I just want to give you an example of all of the components we'll need to put in for a silt fence. We have geotextile, we have the stakes. Some places use steel, some places use wood. So there's some uncertainty that we'll have to do and an uncertainty analysis there. Different types of cable ties, wire or plastic, chicken wire. Sometimes this is optional. Whereas if we go down to the wattle component list, we're going to have some sort of encasement or netting. There's a lot of different types of these. Same things with our fill material, our wooden stakes, and maybe we have an underlay. So we still need to put in all of these components and be able to look at them from an environmental perspective as well as a cost perspective, and hopefully can give the DOT, but also other large construction facilitators, this information so they can make informed decisions when they're selecting what types of practices they'll be using. Now, another area I worked in was in-channel sediment basins. Sediment basins we know as temporary detention ponds. A lot of times these are extra excavations on a construction site that provide for more detention time and volume for construction stormwater pollutants to settle out. This was Iowa DOT's when I first started monitoring, and we can see there's quite a bit of problems with this sediment basin. We weren't trying to do any interventions, just see how some sediment basins were performing. On site, I monitored 3 overall, and they all looked about like this. That we're looking at turbidity over time. And we have red being our influent, or what's flowing into the basin, green being our discharge. And what do you see on this graph? There's not a difference. Now, with each of these sediment basins, the contract price was $3,200 per installed basin. We're spending quite a bit of money on putting these basins in place for them to not work. When you put them in, they look like this. Looks a little bit prettier, but we still see a lot of exposed soil. So no stabilization, and with a high flow, this earthen berm is going to wash right out. So we started saying, well, are these in-channel designs even worth it? Well, we found some pros. It uses existing infrastructure. We see an increased length to width flow path, which in literature shows favorable for sedimentation. Reduced easement or right-of-way needed on a construction site. If we're treating the stormwater within a conveyance channel, I want to point out, this is in a channel. This is not in a natural stream. In a conveyance channel on site, well, then we're not having to have that extra footprint for a really large sediment basin. So we said, how could we make this work? And looked at some components. Stabilizing that exposed soil, putting in a surface skimmer to dewater from the top of the water column, using flocculant, and putting in a forebay. And to Agu's point, we're putting in a forebay to capture those really rapidly settable solids, those coarser particles like sand. That way, our larger volume only has to treat those silts and those clays. And we're not taking up the capacity with these really coarse particles. Okay, so we took this to a controlled setting and we tested what we call the most feasible and effective installation. Now, we looked at each of these components individually, looked at their performance, talked with the DOT, our project sponsor, and said, what do you think? What do you want to include? They said, a surface skimmer seems easy enough. Putting down some geotextile lining or some other stabilization in that basin, that seems like a no-brainer. And putting in this forebay, it's just an extra rock check dam, essentially. And they had that material on site. So those were the three they went with. And then we wanted to test flocculant in construction stormwater. Flocculant's still relatively new. We only see about 30% or 35% of states allowing flocculant in construction stormwater management. Now, flocculant is an agent that helps those really fine particles bind together so that they create larger flocks and settle from suspension more rapidly. In construction, the easiest way to do it is put down these blocks, these flocculant blocks that are essentially like big bars of soap. So this is the sediment-laden water flowing over the flocculant blocks that would then go into the rest of the basin design. And I love to show you visually what's going on. We see on this side our most feasible and effective installation without flocculant. On this side was the same installation, but we had those flocculant blocks in place. So you can use these cinder blocks as reference points, but just visually we're having so much more deposition happening. And when we look at this, with the MFBI, we were able to capture about 96% of the sediment that was introduced to the basin. So pretty good. And with flocculant, we just got up to 98%. And some people will say, Jamie, well, is 2% worth it? And what I want to tell you is that even though this is represented by weight, that 2% is capturing those really fine clays that maybe we wouldn't capture otherwise. And so you have to think, are they really contributing to the weight as much? So then I like to show this graph. This is turbidity over time. So the pink line being without flocculant, the green line being with flocculant. And some things I want to point out, we did a 30-minute filling period of the basin, and then we let that basin dewater for 2 hours. So that's that gap that you see here. Then what happened was that we would introduce filling again for another 30 minutes to simulate a second storm event coming through. Or if the basin was already at some capacity, how would that change performance? And we monitored over 48 hours to look at the dewatering behavior. Typically, we say a dewatering structure needs to allow for the volume to dewater in 48 to 72 hours. Well, with that flocculant, we were able to drop turbidity very quickly, even during the filling period. Now, there's been talk in the past about putting turbidity limits on construction effluent. This is very scary because we have really high turbidity discharges right now. Well, flocculant could be one of those tools to help achieve, but there's a lot of question around if it should be used in surface waters. The other thing flocculant did was help us capture smaller particles. It's like I told you with the weight, but this graph shows what's happening. We were able to take a sample of the sediment deposited in different areas of the basins. There were 3 different areas. These solid lines show this particle size that was captured without flocculant. The broken lines show with flocculant. This general shift toward the 0 axis is showing that we're capturing smaller particles. And so we decreased our D50 by about 50% when flocculant was used. Anytime you're working with the DOT, they say these research results are great, but we need a way to implement them. And so again, created a tool to predict sediment basin performance using soil gradation, different temperatures in the basin, if design hydrographs were available. Now, what you see in red is what would need to be input by the DOT. However, you can omit some of these sections as well and just say, I don't have this information available, and it will give you the best design possible. It then gives the DOT what kind of storage they have on site, what size skimmer they should be using, and if less than 80% of the sediment settled, we recommend using flocculant. And so it tells you should you use flocculant or not. The flocculant is one of the things that I'm really excited about, and I think it could be a path forward in construction. However, there is a lot we need to know about flocculant and make sure that it's safe to be using and discharging, and at what concentrations that do we discharge. So one of the projects I'm going to be looking at is the efficiency and longevity of flocculant blocks. That's what these are. Like I showed you, that's what we commonly use in construction. So one of the first questions being, well, flocculant is helping capture sediment. Is it helping capture other pollutants that could be sorbed to the sediment? And if we're increasing sedimentation rates, can we decrease the size of these ponds? So that could influence some policy changes there as well. What are the residual concentrations? So if we're dosing flocculant, how much of that dose is leaving the basin? If we're doing methods like blocks, what is the dosing? Is it even over time? Is it changing? What's the degradation? And then this, you can see, is a flocculant block covered up in sediment. So what is the maintenance required for these as well to remain efficient and safe? Some other things that we're looking in that I'm working with Dr. Deb Mishra, who's a geotech, and his student on, are tools to predict and manage erosion. When I was in grad school, I worked in GIS using some Russell applications in GIS, but that was just using what's available in Russell currently. So we want to see if we can use these tools to consider modern day precipitation and also projected climate precipitation, and hopefully can develop a GIS-based tool to help with erosion assessment and then also stormwater management planning. So gave you a little taste of where I've been, where I see us going. My main takeaways are that we need to challenge current design standards. Are they working? What can we do to work to make them work? And also consider the sustainability of some of these practices and be looking forward, projecting forward on what issues we're going to face. Engage in knowledge exchange, determine what these problems are. I wouldn't have known what these problems were unless I really started talking to the people that I was working with. So I think formats like this are great. I'm so excited to be involved and listen to what everyone has to say. And then finally, implementation. Being able to develop those technology-based tools on the research side so that these items, this science can be implemented to inform planning and then also resource allocation. So that's all I have for you today. I so appreciate you listening, and I am happy to take any questions. Yes.
What flocculants are you using?
Yeah, primarily a polyacrylamide.
Oh,
Sure, no, that's okay. So the question was, what flocculants are we using in construction stormwater? My answer is primarily a polyacrylamide, and it's important that we know that cationic polymers can have effect on aquatic habitat. So some places will use cationic polymers, but it's very important that those are dosed appropriately. There are risks associated with it, so more often we're using anionic polyacrylamide. And it's more generally anionic polyacrylamide will settle construction sediments. It's very important that you do a jar test or a compatibility test with your flocculant and your soil type.
yeah, we use cationic PAM a lot in agriculture, and the big fear is it's also carcinogen.
Right.
Is the anionic also and that?
I'm not sure is my answer. I can look into it, but I'm not sure on carcinogenics.
That's a question in the chat.
Yeah. Okay, what is the fate of captured sediment in the channel? Is it removed and handled properly or left in place to perhaps erode later? Thank you. Yeah, this is a great question. So your practice can be bulletproof when it comes to performance, but if it's not maintained and the sediment is not properly handled, then what was the point of that bulletproof practice in the first place? So a lot of times, especially, I'm going to take this from the perspective of flocculated sediment. So if we have flocculated sediment and that's been captured in the channel, you can reapply that to your site and seed it. And a lot of times that flocculant will actually help with the stability and establishment of vegetation. So flocculated sediment can be reapplied on site. And that's the same thing if we're getting sediment from that channel. We need to put it back on site, but it needs to be stabilized. If it's not stabilized, then there was no point in ever capturing it in the first place. Other questions? Yes.
This one might be maybe a dumber question, but
No such thing.
how are you guys measuring sediment capture, right? Is it just depth at one point?
No. So which project do we want to talk about? Because they were handled differently.
Right, both of them.
Okay, both of them, sure. So how were we measuring sediment deposition? So in the first project, I talked about looking at it in the channel. So we were doing full surface surveys. So we did a survey pre-implementation, put them in, and then would also do a survey of the sediment deposition, so the top of the surface. And we were using LiDAR for that because we were able to get more precise values. We also did aerial inspections. I was working with another student who was trying to come up with ways to use drones for inspection and how much, what was the efficiency of the results between the drone and the ground. So that wasn't on my side of things, but we were using both methods there.
So with the survey, like, what are they measuring with the survey? Are they
Okay.
just visual, like we think it's an inch, or how do they know?
Oh, okay, so when I say survey, I mean like topological survey. So we're using a LiDAR that sends out essentially laser that comes back, and then it can give you a surface. So it's a full, you'll get a volume, and we would do surface subtraction. So that survey, we take the sediment deposition, so the top of that, and then also the original channel, and we could do a subtraction to come up with what volume was deposited.
So you were looking at elevation difference?
Yes, elevation, thank
Before and
you.
after?
Yes, thank you. Yeah, elevation differences. And then when we were doing control testing with the basin, we knew how much sediment we were putting into the basin. And then lucky for me and the undergrads that worked on my project, we got to go in, shovel it all out, take wet weights and dry weights, and it was over 2,000 pounds of soil per test. So I earned this PhD, I said, if not in brains and labor.
So I'm assuming, you guys, accounted for extreme precipitation events, right?
Yeah, so when we were doing our control testing, the way that we were doing that was coming up with the storm event that would produce 1 inch of runoff. This was came from sizing criteria that informed 3,600 cubic foot per acre for detention space. That was thought to be what 1 inch of runoff would be. So we used the modified universal soil loss equation and some GIS analysis with average soil erodibility and precipitation distributions for the state of Iowa to come up with an average. And then we took our peak 30-minute flow. So there's a lot to those calculations. If you want to talk about it, we can do that. It's just not fun for presentation material normally. Sure. Okay. I think everybody will have access to the recording. That was the question. Okay, yes. The Water Resource Center will put out the recording. Okay. And does the effectiveness of flocculants vary with different type of clays? Yes, that's right. So it's very important that we're making sure that our flocculant and our soil type is compatible. So flocculants are most of the time going to be manufactured products. A lot of times, if you send in a soil sample or like a muddy water sample, the manufacturers will do a testing for you and tell you which flocculant is the best for your soil type. We also do that in our lab, so different match testing based on turbidity, flock size, settling velocity. There's a number of parameters to come up with the best flocculant for you. Flocculant also requires a period of mixing to make sure that that flocculant comes in contact with the soil. That's why, if you remember a few slides back, we put that flocculant in the channel. That way it had ample time to mix and come in full contact. So it needs to be activated. Okay. Also does not take properties of bedrock into consideration. Good news about the recording. Yeah, so we were just using our soil erodibility factors. Again, I'm happy to share that, or even write up. I actually have like a little one-pager on how we did that. So maybe it'd be good to put that out with the recording as well, if we want to talk more about that. Yeah.
So I was thinking about your map of the different DOT state departments that providing information to you.
Yeah.
How receptive have you found them to be changing these methods or?
Yeah. So I would say DOTs, you have departments within the DOTs that are dealing with the environment and stormwater, and typically those people are going to be, want to do well. They want to be environmental stewards. So if you can provide some information like this and say, hey, we did this, these are the numbers, there's a better path forward for change. The problem with these is a lot of times there just hasn't been numbers to put to it. And so, if I told you right now, do jumping jacks without reason, you're probably not going to stand up and do jumping jacks for me. So you have to have the right evidence, of course, but I have found that people are very willing to sit at the table and talk and make the change, especially if you have tools in place that ease that change and ease that transition.
So who's doing most of these designs for the erosion control? Is that consulting engineer, or is that DOT themselves, or?
Yeah,
is it other?
yeah, I would say most typically it's probably not going to be the DOT doing their own stormwater pollution prevention plans. There are businesses and individuals who can do that. Now you do have to be a credentialed person to be able to have a stormwater pollution prevention plan. There are different ways to attain that. I don't know them all, but having a PE is one of them. I have a credential being a certified professional in erosion and sediment control. Those professionals can also do that. So I would say it's probably very broad, but with the DOT, I would say most of the time that service is going to be contracted out. Now, more private developers, I just don't have enough experience to speak to that.
So maybe a follow-up to that, you developed a lot of really cool tools over the years. I guess what rate of adoption have you seen of those? And to me, it seems like maybe there would be a great training, either need or opportunity.
Yeah.
Within Oklahoma and elsewhere for those people that are doing the designs to expose them to not only the results and findings, but these tools that you develop with the design.
Right, yeah, and so that's one thing that I'll say has been a learning curve for myself as well. When I first developed that ditch check tool, I'd only ever worked for the Iowa DOT. In my mind, they were the only people that existed at the time. And so I created that very much for the Iowa DOT with their cost data, in there. Well, then we got approached by another DOT and said, hey, this seems like a really great thing. Could we use it? And sure, the design principles are in there. And it's just a referenced Excel sheet that they would have to upload their costs. They were able to make it work for them. And actually, we're working on doing it for the Oklahoma DOT right now. So they are very, there's a little bit of customization that needs to go into it, but very, very easy, with some basic Excel. You just have to put the right numbers in the right cells. Everything else, the infrastructure should be in place. And honestly, I probably need to do a bit better of a job. These tools right now are hosted on the Auburn University Highway Research Center's page because that's where the funding went through. I think I probably need to do a little bit better job at disseminating them here. And so maybe that's something that we could talk about as well. Because yeah, I agree. I want to do this for anybody who could use it. Yeah.
Training the planners is great. What about training the construction contractors?
Yeah, I love that. I've actually been involved with it, not in Oklahoma just yet. But if you can really, what I have found, if you can show the people who are putting this in, inspecting and maintaining it, what should be happening, it like a light bulb goes on. So if we could be pumping water through these practices and say, this is good, this is bad, and you show that sediment washout, lights go off. Now, that is one of my goals here. So maybe you could help me achieve it. But yeah, I would love to get a training put in place for those people. And even, students who are going to be going out, I tell my students in civil engineering, even if they don't want to work in water resources, pretty much all of them are going to interact with a SWIP at some point. Or need to know about drainage or understand how the site development affects them.
I think oil field workers is another.
Yes, yeah, and even
category.
and with so much solar going in too, that's something we also that's an area too that needs to know some of this information. So yeah, I'm very passionate about it. I love outreach. I love getting the science to the people who need it. So yeah, I'm always looking for opportunities and happy to jump in as well.
I have one more
Sure.
Question. Does Oklahoma allow use of parking?
Right now, no. We've been talking about it quite a bit. So yeah, I do have some contacts at the DOT trying to figure out. It's not being used. It's really not being used right now. And it could certainly be a tool because we know we have lots of sediment impairment in the state. Some of that from construction, not all of it, but definitely it could be a tool to try to mitigate some of that. Thank you so much.
So much. All right, well, thanks everyone for joining this. Our next one will be on September the 21st at noon, and we'll have a guest speaker from the Oklahoma Department of Environmental Quality, Shelley Chard, who's the Water Quality Division Director there. Will be speaking about the circular water economy. So hopefully you can join us then. But thanks everyone for being here, and have a good rest of your day.